All right, we are starting Chapter 1, Section 3 for Properties of Numbers. This is for IM1 or Integrated Math 1. So I've been starting these videos off the same kind of way. This is the exact screen you will see as a student working on ALEKS this year, with the exception of a few things. So you will see a due date here. I don't see that on my teacher preview page because I don't actually have a due date on mine. But you will have one on yours. You always have attempts here. It'll show you which attempt this is. So this is the first time I'm attempting this one. I have unlimited attempts. Everybody does. So you can come in and repeat this as many times as you would like. And this particular assignment has 8 questions. You'll have anywhere from 1 to 10 questions. Grading policies, best score. So whichever attempt is your best is the one you get to keep. And partial credit just is always on, which means, if you answer 1 of 8 questions, you get credit for the 1 question. Always remember to submit your homework. There will be a submit assignment button in the bottom right corner of your screen. You're not going to actually see it on my screen here because it's the teacher preview, but you always want to submit it because otherwise it's going to lock you out of every other assignment until you submit this one. So you can't do anything else. So always click that one. You can come back in and try again. Remember, unlimited retakes. All right, let's go ahead and click start here. On the side, once this loads, you always have these 3 features. So explanation, it will explain this exact problem to you. Not an example problem, this exact problem. So it gives you the answers here. It shows you how to do this and it gives you the answer. So it's saying you're going to lose your current question attempt because it's not going to give you the answers and then let you type them in. So it's a really neat feature because you might just be stuck on this particular problem, not necessarily the problem type, but maybe this problem is in a format that you don't quite get, so you can see it explained to you, and then you can come back in and try it again. Okay. Example just gives you a basic example of how to do things, how to complete this type of problem, so you can read through and go, okay, I get it, and then close it. If you want another example and you open it, it's actually a new example, not the same one. And you can message your teacher, with this problem attached so we know exactly where to help you. All right, let's go ahead and get started here. So for this one, we are completing properties of numbers. So first, we're going to review a little bit of exponents here so that we can take a look at what happens with negatives when we're looking at exponents. So remember, an exponent does not mean that we multiply the negative 7 times 2. It's telling us how many times to use the base. So if I have a 2 for my exponent, then I'm going negative 7 times negative 7. It means I have 2 negative 7s. And a lot of the time we put these in parentheses when they're negatives, just to keep them a little bit separated. So whenever we're multiplying negative numbers or dividing, 2 negatives make a positive. So negative 7 times negative 7 is going to be a positive number. And then we can just focus on the numbers here. 7 times 7 gives us 49. And again, if you're having trouble with your times tables, if you didn't quite know that one right off the top of your head, I would definitely suggest going into quick tables and kind of practicing that. We have quick tables for addition, subtraction, multiplication, and division. And it's literally just practice with your math facts to make this a little faster, a little easier to get through. All right, so we have 49, so that's positive. So now we're going to look at the second one here, and we have negative 4 cubed. Remember, that means negative 4 3 times, not times 3 times. So I have negative 4 times negative 4. 2 negatives make a positive 16, and now I'm going to multiply the 16 by the third negative 4. So I have a positive times a negative. My answer comes back to negative because a positive times a negative gives me a negative. And then 16 times 4 is 64. So one thing we do want to notice on this one, and we talked about this in class, I believe, on the other notes page, if you have an even exponent, your answer should be positive because you either had 2 positives multiplied together or 2 negatives multiplied together. So it should be a positive answer. If it's an odd exponent, it'll either be positive if you have a positive to start with, but if you're starting with a negative, you're going to end with a negative if it's an odd. So it kind of depends there. It's not just a final, it's going to be negative or positive. It depends on what you start with. So if you start with a positive, you'll end with a positive. If you start with a negative, you'll end with a negative when you have an odd exponent. But if it's an even exponent again, it should be positive. They should cancel out. So it doesn't matter if it's 2, 4, 6, 8, 10. Every time you multiply two of them together, the negative signs cancel out there. So it ends up completely canceling. All right, let's go ahead and check that guy and move to the next one. Okay, so there's a little bit more review. We did this on the last homework assignment too, where we were evaluating some expressions. So we have negative b plus 2y. And then they're telling us what b and 7 are. So with this one, we just need to plug in our numbers. So this is just a practice in substitution. So if we know b is now 4, remember this negative is going to follow it down. That doesn't go away just because 4 here is positive. It's negative b. We're just replacing the b, not the negative. And then plus 2 times, well, now we know y is negative 7, so we're going to multiply by negative 7. We need to follow the order of operations here. So I have to do multiplication first. 2 times negative 7, that gets me negative 14. Positive times a negative gives me a negative. And I can put the plus sign here. You can also say negative 4 minus 14 if you didn't want the plus sign there. It means the same thing. Now remember, if we're thinking of this on a number line, and I have 0, 1, 2, 3, 4, here's negative 4, and I'm adding negative 4 to it, or I'm saying minus 14. This is my negative direction. This is my positive direction. It means I'm going more negative. So I need to add these two together in order to get the correct answer. So I'm going to add them together. I'm going to get 18, but it was negative. I'm going more negative. So I get negative 18 in this case. Negative 18. Check. Perfect. All right. And it's funny, this acts a little bit like a whiteboard. I have to erase twice to get it to go all the way away. Okay. So we're going to continue this practice where we're evaluating an expression and we're substituting in the value they give us. So they're telling us to evaluate the expression when m equals negative 3, and here's my expression, m squared plus 5m minus 4. So I'm going to take this, and I know now m is 3, or negative 3, and I'm going to square that, because there's a square here, plus 5 times negative 3, and I'm using the parentheses as a way to show multiplication there. Instead of the dot, means the same thing. So remember, this is not negative 3 times 2, it's negative 3 2 times. So negative 3 times negative 3. 2 negatives make a positive, so I get positive 9. 5 times negative 3 gets me negative 15. So you could leave it as minus 15. You can put the plus sign in here if you want. It really means the same thing, because sometimes we'll have it like this, where you have negative, or 9 plus negative 15. But you could also just leave it as 9 minus 15, and then minus 4. So now if I'm thinking of my number line, and I have 9 here, I'm saying minus 15, so I'm going to subtract it. I'm going to take 15 away. And 15 is more than 9, so I'm definitely going to be in my negatives here, right? So if I subtract these, that tells me where I'm going to land on this negative side. So 15 minus 9, well, that's negative 6. And I'm just kind of guessing there on where it would be. And now I have to take away 4 more negative 4, right? So I'm going to go 4 more negative, and I'm going to land on negative 10. So just the visual kind of helps us with that, just so that we can tell where we're going. So negative 10. But if it's opposites, we subtract, and the bigger number kind of tells us what our sign's going to be. So 15 minus 9 is 6. 15's bigger, so it's negative 6. If they're the same sign, negative 6 and negative 4, all right, well, now I have to combine them and keep the negative sign. But the visual definitely helps you remember, okay, I'm moving negative. I'm still moving negative. It's just a very nice way to know which direction we're moving. Okay. All right, so with these ones, I don't think I'm going to necessarily write these over here. I'm just going to talk about them on this side. So this has to do with properties and what we're seeing here. So when we go through, and these all have this same drop down, we have associative property, commutative property, and identitive property. And if we click on the example, they will give us the definition for these, I believe. If we look at these, well, they kind of give us the definition for them. I was hoping they'd give a little bit better definition there. So commutative property has to do with the ability to move around without changing the problem. So with this one, they're showing they filled it in with 9 here because 8 plus 9 is the same thing as 9 plus 8. All they did is switch spots there, right? As long as it's all addition or all multiplication, you can flip these around. You cannot do that with subtraction or division. Only addition or multiplication. You can kind of switch them around. So we call that commutative property. And I think of like commuting, moving around the community. Identity, so this has to do with what would I add to a number so that it doesn't actually change. Its identity stays the same. Well, that would be 0. That's the only number I can add, and it won't change. So that's the identity property of addition. I believe we're also going to go to the identity property of multiplication. So if we think about that, what do I multiply a number by so it doesn't change? The only thing would be 1. If I multiply by any other number but 1, it's going to change it. But 1 leaves it alone or makes it the same. So its identity stays the same. And then the associative property, and if you've ever heard, who do you associate with? It's, who are your friends? That's the idea there. So I think of that when I talk about grouping, because that's what associate means. We're grouping them. So if you notice in this first one, it's 2 plus 4 plus 6, and they filled in the 2 up here, but they have 4 and 6 grouped. And then in the second one here, they have 2 plus 4 plus 6, same numbers, but now they've grouped 2 and 4. But since it's all addition, it doesn't matter how I group them. I can group them in a way that makes it easier for me to add those 2 and then add the third piece. Excuse me. So this just has to do with grouping addition or multiplication, but they have to be all addition or all multiplication, and I can group them however I would like. So that's all we're going to kind of focus on for this one, are those 3 definitions or 3 properties. So with this one, I can see the grouping. So as soon as I see the grouping, I know that's associative. I just need to make sure I fill it in. So it's 2 plus 9 plus blank, 2 plus 9 plus 4. Well, it has to be exactly the same numbers. I can't change the numbers. I'm just changing the ones that I'm grouping here. All right, with this one, I have something plus 5 equals 5. Well, I didn't change the identity. The only thing I could add to 5 without changing it would be 0. So that's on my identity property. And then down here, it's 8 plus 3 equals 3 plus, well, that has to be 8 in order to be true. Again, we want the equal sign to be true. All I'm doing is switching the position. So 8 was first, now 8 is second, and the second one, right? So this is the commutative property. I moved them around. Alrighty. Let's go to number 5 here. Okay, so it looks like we're going to do a few new principles. Let's see. So we still have commutative, we have associative, we have identity property. We don't have identity, additive identity property and additive inverse property. So they're specifically saying additive identity property instead of just additive. And then inverse property. So that's a new one. So the inverse means the opposite, or what gets you 0 when you add to it. So if I have 5 and I want to get to 0, I'd add -5, or I'd subtract 5 from it. If I had -10 and I want to get back to 0, I need to add 10. So it's always the opposite. That's the additive inverse property, is we're trying to get back to 0. So when I look at this one, I see 0 equals x plus -x. I don't know what the x's are, but they're the same, with the exception of one's positive and one's negative. So that is the additive inverse property because it gets me down to 0. So this one, I have 0 plus a equals a. Well, remember, if we add 0 to anything, it doesn't change its identity. So that's the identity property. And on this one, I can see the grouping. So immediately I should understand that's associative. Grouping and associative go together. And I can see it's 6 plus 5 plus B, 6 plus 5 plus B. They're the same numbers. It's all addition. I'm just moving the grouping around. So we have associative property. Alrighty, so let's keep trucking along here. We have number 6. So we're going to fill in the blanks here, and this is for multiplication now. So the properties actually are very, very similar, and we've already kind of talked about that on the other pages, right? Associative, it's the same idea. It's going to be with grouping. We're just moving the numbers around. Commutative, same idea. We're going to switch the position of the numbers. Identity is a little different. Like we talked about, we're not going to be adding 0 anymore because now it's multiplication. So the only thing I can multiply by a number, so its identity doesn't change, would be 1. Anytime I multiply by 1, it doesn't change the number. 0 property, that's a new one. So 0 property means if I multiply by 0, I get 0. So that's all 0 property is. This is just the idea of multiplying by 0. So with this one, I'm multiplying by 5 by something to get 5. Remember, the only thing that I can do that with would be 1. So it doesn't change the identity there. So that's my identity property. 2 times 6 times 9. 2 times 6 times has to be 9 because it has to be the same on both sides. And all I did was move the grouping here. So remember, grouping goes with associative. I'm moving around those parentheses. I have 6 times 0, and most students are going to definitely know that equals 0. Remember, when I multiply by 0, that is my 0 property. And then on this one, we have blank times 8 equals 8 times blank. So I'm multiplying 8 by the same number on this one. It's going to be 9. All I'm doing is switching the position. 9 is first in the left side. 9 is second in the right side. But I still have the same numbers. I'm just commuting them. I'm moving them around. All right. Couple more of these guys and we will be all done. All right, so choose the property of real numbers that justifies the equation. So now I believe we have a whole bunch of these. So we've already talked about all of them. We need to make sure we're choosing the correct one. So now of addition or of multiplication. So we have to choose the right one. The only one we haven't seen yet is distributive property. I think the next section actually focuses on distributive property. So I'm not going to focus on that too much yet because we're going to take, oops, knocking stuff down here. We're going to take an entire section to go over that one. But if it comes up here, we will go over it. It doesn't look like it's coming up quite yet. It's just on the list. All right, so when we're looking at this one, we have 0 times A equals 0. All right, I'm multiplying by 0. That was my 0 property, and it's multiplication property of 0. So it's not always going to be named exactly the same thing, but the words are still there. It's the 0 property of multiplication or multiplication property of 0. D times 2 equals 2 times D. All right, well, all I did was switch the position. So remember, that's commutative, but I need to make sure I choose multiplication property for this one because I'm multiplying. So I'm going to go down commutative property of multiplication. I don't want to choose addition. I'm not adding. I'm multiplying. Okay, the second one, or third one, I mean, we have 8 plus n plus 6. 8 plus n plus 6. All I'm doing is grouping them differently on both sides. So immediately we should know that's associative. Hopefully at this point I've said enough in the video that you're identifying associative with grouping. But we need to make sure we're adding, so we choose associative property of addition, not multiplication. We're not multiplying. So we want to do this first one. We don't want to come down here and go, oh, this one's associative too. That's of multiplication. We want addition. All right. M times 1 equals m. So I'm multiplying by 1, and the identity of the number is the same. It's still m after I multiply by 1. So this is an identity property because it's still the same number, but it's identity property of multiplication. So multiplicative identity property. Multiplicative. I'm saying that funny. Sorry. I don't know why I can't say it quite right on the video right now. All right, we're going to go ahead and check. And I think we only have one more problem left to do. Yay. Okay, write two expressions for the perimeter of the figure. So when we're looking at this, first we need to know what perimeter means. If we don't know what that means, let's see. Do they give us the definition on this one? So they do. They say the perimeter of the figure is the sum of all of its sides. And then they show you they're adding up all of the sides here. So that's what they show you here. And that's actually exactly what they want us to type in here, are just these pieces. And then they want us to simplify the expression from part A, which just means add like terms. And you can see that they've color-coded it here. We have a constant, a constant, a constant, and constants just mean they're numbers with no variables. It's just their regular numbers. And then we have 5x and 8x. Remember, this is 5 of something, 8 of the same something, so we can combine those. Those are like terms. They need to be the exact same variable, and if once we get into using exponents with this, it even needs to have the same exponent on it in order to add them as like terms. So we have to be careful about that, but as long as they're the same exact variable with the same exact exponent, in this case there's a 1, even though we don't see it, we get to add those as like terms. So with this one, the big thing is if you don't know what a word means, if you didn't know or you couldn't remember what to do with perimeter, you definitely either want to look at the example or look it up. What does that mean? So that you can complete this problem. So with this one, we want to start typing it in, and it doesn't matter what you type in. So I can start here and I can go 8x, and I can go to the right and go 18, 13x, and 6. So this is one possible answer. Or I could even back up and I can group my like terms and go, well, I want 8x and 13x to be near each other, like this. And I can go 18 and 6, because those are constants, so they could be near each other. I get to group them however I want, and I can commute them around. As long as I'm adding them all together, it doesn't matter in what order I add them. I'm being a little dramatic about that, but it really doesn't matter what order you add them in, as long as you get all 4 pieces here, or however many pieces your diagram has. So now, if I add like terms, and I grouped them here, because I did it a second time, if they weren't grouped, that's fine. You just make sure you identify which ones are like terms. So I have 8 and 13, and that gives me 21x, so 21 something. I don't necessarily know what the x is. Plus, I have 18 plus 6. So I need to combine these guys, and I get 24. All right, that should be all for this one, and we are good to go. So that was section 3, and I will see you in section 4.